Welcome everybody to this panel where we'll be talking about LLMs and the impact on the workforce. So first we'll do a quick round of intros, then we'll discuss a few kind of initial questions, and then we'll be taking questions from the audience. We're very excited that you're all here. It's a full house, and we'll get a microphone to you when you have questions. So yeah, first of all, my name is Jan van der Vecht. I'm a product manager at Databricks, working on workflows as well as on some LLM-related topics. I have a background in deep learning, and I'm very interested in kind of like how this revolution is going to kind of shape the future. Debu?
Hey everyone, so this is Debu Sinha. I'm a senior specialist architect working with Databricks for about 5+ years. I've been with this company since the journey with all the machine learning related products, like went from initial stages to maturity. And I have a background in natural language processing. That was my research area. And now I focus and work with digital natives, startups, and our growth customers. So happy to answer your questions.
Ankit?
Yeah, great to see everyone here. My name is Ankit. I've been at Databricks for a little bit over 4 years. Currently, I work on model serving for GPUs and large language models. Also helped create Dolly here at Databricks, and so I'm excited to chat about everything LLMs.
Hello everyone, my name is Benjamin Harvey. I am the founder and CEO of AI Squared. I'm also director of designing. This mic has an echo. It sounds like God is.
Yeah, you can try this one.
And I'm also the director of designing trustworthy AI systems over at George Washington University. If I go back to about 10 years ago, I worked at the National Security Agency, where my last 2 positions, I was the chief of operations data science, and I was also the head of data science for the Edward Snowden leaks. I did have a past tenure working in the early days at Databricks as well, before founding AI Squared.
Cool. So let's get started with the first questions. So the first view will just be about LLMs in general, just to kind of like give a quick intro for people who are maybe kind of less familiar with the topic, and then we'll slowly go towards the
microphone at present. See how this works. Okay.
So Debu, can you give us a very brief summary of like how LLMs work, like both during training and then at inference time?
Yes, so large language models were essentially trained on a very large corpus of data throughout the internet, and that's where the main intent is. Like when the model is trained, the model understands over time in a sequence like what next token to generate based on the context that it has beforehand. So during training, most of the time when we look at all these large language models, like if you're fine-tuning it or even training it, you provide it with a large corpora of your personal data. For example, a QA bot that we have on Databricks, we provided it with sample of our knowledge base. It learns from the sequence of all the information. We provide it with, it trains what the next token, makes prediction on that when the natural query hits it, and we provide it with prompt. So that's how large language models go in training, and during inference time, you just provide it with a context, and then it tries to map based on probability what kind of query matches or what tokens it has seen in the past, it has learned on to generate that inference. So that's how large language models really work. But just keep in mind, they don't make any inference based like we as humans make and give you the output. It's based on some probabilistic calculation what they have seen in the past. So.
All right. So the next question is, so what are embeddings? And you've probably heard things like vector database, and how do they relate kind of like to LLMs? And I'll briefly answer that myself. So the way that these deep learning models or transformer models work is by, as Debu was mentioning, by kind of parsing these tokens and then predicting the next ones. And the way that these models work is they're basically very large kind of mathematical functions, and they learn some intermediate representations that captures the semantic meaning of all these tokens that it has seen already. And this representation is basically a large vector of numbers, and that vector encapsulates what it has seen. So it's basically a byproduct of trying to predict kind of these next tokens. But there's a lot of value in these embeddings, because that even if two sentences are very different from a like word by word perspective, if they mean very similar things, these models will embed them into vectors that are very similar to each other. So what it allows you to do is, if there's new queries or information or documents that you put into this model, instead of trying to predict kind of next tokens, you can take this embedding and store it in a database somewhere, and then search in that database for other vectors that are very similar to it. So you could retrieve kind of documents that are relevant to the query, and then you can do all kinds of things with that. Either directly return these to the user, or you can take information out from there and inject it into the prompts for generation, etc. So this is a way for LLMs, or like LLM-based systems, to take information from external systems and use that together with like just the model weights that it was trained on. Ankit, can you kind of elaborate what some of the limitations of LLMs and kind of applications based on LLMs are today?
Yeah, certainly. We're definitely in the early days of this technology, and I mean, if you just look at what's happened in the last several months, LLMs have come a long way from even just like what we released with DALL-E to the newer models like MPT 7 billion and 30 billion that are much more coherent at talking to humans. But I think Debu hinted at some of the limitations, right? Sometimes it's difficult to get things like chain of thought reasoning that's kind of required in order to get an accurate answer to something. And that's where helping out the LLM with stuff like vector databases that are injecting relevant context into the large language model's context is important, so that that model can both give an accurate answer and give a source for it. Without such information, the models are often prone to hallucinating incorrect answers very confidently. Because, you know, like he mentioned, they're trained to speak confidently, even if they don't necessarily have all the facts.
All right. So Ben, when you kind of look at it, not just from the limitations perspective, but more broadly on how these models can be applied and are maybe already applied, like what are some generic risks that associated with applications built on top of LLMs?
Yeah, great question. So one of the things that you know, we have to think about from, you know, traditional machine learning, data science ecosystems compared to large language model ecosystems is, you know, we have data scientists in organizations, and historically it's really been the wild, wild west, right? So you're able as a data scientist to kind of experiment, bring in different data sets from different locations, train, you know, what we believe to be world-class models in a lot of instances where you get it in front of a customer and they're like, yeah, this is not actually really a world-class model. But the idea is that there really are no true guardrails when it comes to, you know, the experimentation and building these models inside of a sandbox. So one of the things that's really important, as we're going to see as time goes on in the near future, is really from a governance, policy, compliance, and a security perspective, more guardrails that are actually being applied to support best practices and governance while you're building, while you're training, and while you're deploying these models inside of a sandbox, but also as we go from a experimental environment to a production environment as well.
That's a very good answer, thank you. So the last question that we have prepared before giving the microphone to you is kind of a step towards the general topic. So Debu, how do you see kind of like on the short term LLMs impacting people's work, and maybe not just the work of the people here in the audience, but more broadly?
No, absolutely. Actually, this is pretty close to the work that I do with our customers here at Databricks, because most of the businesses, when they are looking at LLMs, there are two separate groups. They have the technology users who understand these data engineering pipelines, how they work, they understand how large language models, or they have worked with all these deep learning technologies. But there are actual business users who want to simply ask the question in the most natural language, which is mostly for all of us is English. Like, I want to just get to the answer from my data. Like, if I can magically start to say, hey, can I get the total sum for my product for this particular month, or maybe I want to get the regions which are doing best for a particular product, or get back to my, if I'm looking at a marketing campaign, I want to do some analysis on what kind of segments are my most profitable ones. Like if I can simply write, or my business users can simply write those in plain English without worrying about technology, that's why it will actually improve the productivity of so many of my employees. Like now they don't have to depend on data engineering. They don't have to worry about all the pipelines or scaffolding behind the scene, how to enable it for my, for the larger organization. They don't have to go back to a shadow IT or maybe an IT organization to ask for these data sets. So the time to market and the value that your data is having, you can make use of it as soon as possible. So this is just one example of this. As Ali also mentioned in today's keynote, that Lakehouse IQ, the product vision that Databricks have, like all the components from your data context, like with large language models, if you're using the open source version, you can actually start training it on your personal data and then make it into your champion. Like it's not going to work on replacing the work people are doing, but making it more efficient. Like everyone here will become a 10x engineer. And I believe it was the JP Morgan Chase session today in which Jamie was, he was saying that, oh, now I can also program in Python as good as everyone else. So I think it will be a productivity booster for everyone, and it's really a good thing that you all are here and getting upskilled on this as we are looking at the state of the art that is possible and how the vision of Databricks is going in that direction. So.
All right, thank you. Are there any questions from the audience?
One, two, three. Thank you. So I have a quick question about what are your thoughts that how well the large language models understand? And there's a debate that whether they understand or mimic the language that we are doing. And for a lot of tasks, for example, for the personal information, if I want to have an assistant, I really want my large language model to understand the concepts, not mimicking or saying something that makes relevant in English, but more of concepts. So what are your thoughts? And for a lot of businesses, I know that they want these concepts rather than a very general question answering platform. Also, what is the follow-up is how will they work in a multimodal scenarios? Thanks.
Okay, so I think to summarize the question, if I understand it correctly, is like how well do these models actually kind of understand the intent or like the context in general versus like how much of it is just kind of statistical, kind of next token prediction? And then the follow-up question is like how well do these models actually work in a more multimodal environment where also things like text and audio can be combined? Yeah, let's start with the first question. Maybe Ankit.
Yeah, so I think this is a really interesting topic, and one thing I would reframe almost is the question of what it means to understand as opposed to mimic, right? I think there is emerging evidence from the research community that language models are able to like understand concepts in your sentences, particularly at different layers within the transformer. But next token prediction is kind of the mechanism by which these models talk. That doesn't necessarily mean that they're just like kind of parroting things that they don't understand. However, it is really hard to measure what it means to understand a concept. And so there's actually some pretty cool research from MIT, and actually we at Databricks just had a speaker present on this, where they did prove that models were able to understand things about how code was written when they were reasoning about how to write code. Now, understanding at what granularity, did they understand what a class structure is? Did they understand what a function is? It's very tough to answer that question. But I think the path forward for those of us who are practitioners is to be really, really data driven on understanding accuracy of answers and using that maybe as a proxy for understanding. But yeah, I don't know. Well, let's see what the other panelists have to say.
Yeah, maybe do you want to elaborate on the question or answer the multimodal question?
Yeah, I'll elaborate a little bit there. I think one of the things that we're seeing, especially with one of our Fortune 100 financial services customers, is really that they're looking for an understanding of intent, where a lot of times the challenge is, the individuals in the organization that are using these different technologies are using them for different purposes, and they're trying to figure out how can we gather insights based upon behavior that we can add into the prompt to help with the understanding of the actual intent. And if you think about on the other end of the spectrum, it's the response itself, right? Which, to the point of the question, it's not a lot of information that you would need for an organization to kind of take the insights and, in a sense, that they're actionable, they're relevant, they're contextualized enough for you from a human-machine teaming perspective to be able to take that information and, for, an analyst or for a frontline worker in a sales and marketing organization to take that information and make a decision on it. So there's other mechanisms that are in place where the insights that you're deriving from the actual creation of the response itself, we're trying to gather additional information from the organization, whether it's from other data sets or from other models, chain that together and then provide additional contextualization so you have enough when you think about what's necessary to be able to make a data-driven decision on that information and have trust that it's the right decision as well.
Yep. Maybe to add a more anecdotal thing is like, as Ankit was mentioning, like understanding is not a very well-defined term by itself, but I do think that it's also just not very binary, and one kind of use case, which is not really a useful use case, but a very interesting concept that I've played around with GPT-4 was the fact that I believe there's some level of understanding because a prompt I asked GPT-4 was, can you explain Spark to me with an analogy of a farm? And it did it so extremely well, like mapping concept from a farm to like distributed computing, that to me indicates that there needs to be some level of understanding what these concepts mean, because otherwise you could never kind of like map those two completely different worlds to each other. And I'm pretty sure that nobody wrote a blog post explaining this analogy. I guess I should check that, but.
Yeah, and by the way, one last thing I would mention is like, for you as a business user, when you think about, can my model understand stuff within my company's context, it's tough for the model to understand if it's never seen that kind of information before. Just as it would be tough for any one of us to like join an organization and start answering questions immediately about things that might be going on. And so that's where like training your model on your personal data is extremely important in order to even give the model a chance to understand that. And certainly one approach is to like put stuff in the context, and that works quite well now. But I think if we look into the future, I'm actually pretty optimistic that people might be able to train much smaller models, but really have them understand the concept specific to their company so that they're able to actually understand, to your point. Because that building of understanding actually starts to happen in training. But if you're using like a frozen model and then expecting that to learn from the context, that's much harder to make sure it gets right.
All right. So maybe for the second part of your question around multimodal, Debu, do you have any kind of insights around multimodal models?
Yeah, absolutely. So most of the time, you can have all these different models. Like if you have a multimodal architecture, you can create a vector embedding just for these different. At the back end, like machines require binary bits and bytes to understand what your data is or your query is. Even when you're converting a natural language into a vector, it's essentially converting it into an array of integers or floating point values and then doing cosine similarity on that. So when an image is inserted, even that is converted into a vector. And then you can perform RGB like segmentation or remove the coloring from it and convert it into a smaller subset of the image and then concatenate them as an input to your model to generate different sorts of output. So I have seen use cases like that when people are submitting an image and the caption is generated from that image. So auto caption generation is a good example of that. So that's how behind the scenes, like different types of input you can provide and your model can start to make patterns out of it.
Yeah, and maybe one thing to elaborate there, like as Debu was mentioning, in the end, these different types of unstructured data is mapped to a learned embedding. So these models learn like how to represent these, and there's nothing preventing you from building a deep learning network like that can take one or multiple models at the same time, or even where you can learn embeddings that you can search through, where you can either input text or images or audio, and as long as you make sure that these embeddings are aligned some way, you could even, like map one mode to a different one. All right, so thank you for the question. Anybody else who has a question?
Here's another.
Okay.
Hello. I have a general question about LLMs. Like, how often are you retraining these LLMs? And when you retrain those models, are you using the entire data set or only the delta that got accumulated from the previous train time?
That is a very good question. Ben, do you have any insights?
Yeah, a very good question. So one of the things that we're seeing, depending on the actual customer segment that we're actually working with, the first thing that these organizations are doing with deploying these large language models at scale inside of these different organizations is that they're running, more of an observational study, right? So what they'll do is they'll, have, a handful of potential kind of early stage users that will get their hands on the actual technology itself. And they'll run these studies for a number of weeks, and they'll gather information on, whether or not the model was accurate, was the model, if it was inaccurate, right, what was the correct answer, right, for an example. And if it was also incorrect, can you provide me with additional context for why the model was incorrect? They're getting information about the performance, all the way to information about whether the response was nonsense, was it relevant or not. So all of this information is a part of the metadata that's associated with the study. And this is allowing these organizations to determine, right, do I need to retrain the model before deploying, or based upon the feedback, is the model ready for, at scale production level usage? Now, one of the things that we're also seeing is that traditionally from a autonomous AI and machine learning perspective, when you think about real-time, information that's necessary to make a decision, these models have been, historically kind of deployed, and you do like a autonomous, automatic A/B testing, right? Where you kind of, assess the model in real time, and you kind of make a decision based upon the accuracy and the performance of that model in a production environment. But it's all on the testing end of the spectrum. So now what we're seeing is we're seeing observational studies with the human in the loop the entire time that the actual model is in a production environment. So once they figure out that it's, past a certain threshold and they're ready to actually deploy it in the organization, they gather the feedback, determine if they need to retrain, but at the same time, once they do deploy, they're still running these observational studies with the human in the loop that gives them additional information as to when they might need to retrain that large language model as well. So it's a continuous process is what we're seeing in these organizations.
Actually, I would like to add something there. So the time when we launched the Dolly 2.0, at that time, a webinar came out. And in that, like one of my coworker, like Sean Owen, like he's the principal architect, he created a very awesome demo. And in that, we are not really retraining the model, but we are utilizing the new data that you have in your organization. We index it into one of the vector databases, ChromaDB. And then at the time of inference, you simply use one of the latest state-of-the-art, maybe language models, and then you provide that as context, like whatever query, if you have a query in natural language, you send it, it encodes it into a vector, do the vector similarity of it, gets the most relevant documents or set of answers, feeds that as context, and your language model is able to determine the answer to that question based on the latest knowledge. So even in Databricks, when we have, if you go to our website, there's a Q&A bot. So the way that is working, as well as soon as our knowledge base is updated, the documents, the latest documents make their way into the ChromaDB or the vector DB. You don't have to fine tune or retrain your model every single time. So the way to keep your knowledge fresh is to keep that data set, that vector data set fresh. That's one way of doing it. And we recommend fine-tuning as one of the options which you should take only if you think your model is not knowledgeable about the different terms, that maybe some medical terms which are very specific to your industry, your language models don't support it. So at that time, we recommend that only in that scenario when you want to teach your language model to learn something new, which it has not seen on the internet or the language, then fine-tune it. That may help to get more results. But
yeah, maybe one last remark there. Like, I think it's at the moment not super clear from a more technical perspective, like things like forgetfulness. Like if you, let's say you have a large corpus of data that you do want to train your model on, it's not entirely clear, like if you keep every week, like add the deltas, like train the model on there, how much of the kind of original data is still kind of incorporated in the weights. So I don't know of any research in that regard, but I can imagine that you want to like add some of that older data into the training loop to make sure that you don't like only focus on the more recent examples.
Yeah, I mean, just to tie it up, I think frankly we don't know. Like the vector database approach is one approach, but I think we're super early here. And we're going to have to wait and see to understand what the right approaches are as people move it to production.
Yep. Any follow-up questions?
Thank you. So we just saw OpenAI released capabilities for functions in response to chat queries as part of the latest model, and obviously AI agents that can use tools is an area of tremendous opportunity. So I'm curious if any of you on the panel here have started to explore use of AI agents in order to improve productivity or solve kind of business challenges that you're seeing.
I can give an answer to that. So I'm not going to give any comments on OpenAI specifically, but I have played around with the concept of agents. So maybe for people who are less familiar with this, like regular LLMs, the idea is you put in a prompt and you generate kind of an output. You can have some control over what that output looks like. But with an agent, the idea is that it's kind of an iteration where the agent can decide kind of what's next. And that could be selecting from a few, like a small set of tasks or like things to do, which typically translate to different prompts. And then based on that, kind of do next actions, which can include doing a Google search or calling some API, things like that. My experience with those is that we're still very early days, and that these agents are not nowhere near good enough to achieve real-life tasks. They make for very good demos that do really well on Twitter, but playing around with them, personally, I've been fairly disappointed. But the concept of functions in OpenAI, that's just about kind of like enforcing a certain structure in the output so that you can use that in downstream applications, where it's not just about generating some output and presenting that to the user or generating an embedding that you can use to search for, but as a more structured output that you can represent in a table in your website or use for API requests directly.
Yep, another question.
Okay.
Just a fundamental question. How do you define a vector for a specific context? For example, you're doing image processing versus conversational versus whatever else. So what does that look like? Just the anatomy of it.
Ankit?
Sure. Yeah, just really briefly, a vector, like you can think of it as a space of similarity between things, right? So when you think about words and sentences, you can map those into a multi-dimensional space, and some of those will be similar to others, and that's what a vector search is doing, right? So what's happening when you ask it a question is that it's taking that question and it's trying to find other articles it has that are similar in that vector space to that question. Similarly for images, you might do something like the same way, right? Images can be mapped into ones and zeros, and you can map those into a vector space as well. And then you might be able to group all the images of like fish and then all the images of other animals and things like that. And so then you would perform a lookup in that space. So that's what a vector is. And when you, the way it interacts with the large language model is your input is mapped into that vector space, and then you pull up the relevant stuff. And then you put that relevant stuff directly in the context. So that's a little bit about how it works.
Maybe if I understand your question correctly, it's like how do you map kind of this text into an embedding? Maybe you can elaborate on that. Like how do these embeddings actually learn?
Yeah, so absolutely. So this is something which is not new. Machine learning models can't understand language. They don't understand an image per se. So, and in the background, like they require bits and bytes to work with and to understand. So for images, there were already models that were available like ResNet 50 or other models are there that understand how to take an image and then convert it into a vector space. And that was used as an input to a model. And then based on whatever task you're working on, whether it's classification or maybe you're trying to have any other generative AI model that creates a similar kind of image, like they all work off that encoding of your data set that you have provided. So typically when we are looking at as like how to create that embedding, even with the large language models, we download it and they have a component called as encoders. And those encoders are tokenizers. And those tokenizers take those input language queries that you have and then convert it into a vector. And then that takes, the model itself understands how to take that vector and interpret that back to natural language, or they have internal representation of them. So depending on what is the type of input, maybe it's sound, maybe it's image, maybe it's a natural language, they all have those type of encoders and tokenizers to understand how to interpret them into vectors. And then as we were talking about that, you can have vector space in which then you can perform the similarity matching. That's how it works.
We have another question here.
I have a question about implementing in the lakehouse. It might be out of scope. You can just say it's out of scope. I'm noticing that it's difficult to put LLMs into Databricks if in the event that I need to scale out to multiple GPUs, and the answer is typically Ray, and that is complicated on Spark, and there's other ways of doing it. I'm wondering if Spark versus Ray, what the architectural decisions are when implementing large LLMs. And it could be out of scope, but you could say so.
Well, we should definitely chat after this. That's my whole job. So I think LLMs in production, for those who saw Patrick's keynote today, is a really big focus for us. We actually just announced that we're doing this thing where we can serve LLMs in an optimized way so that it's like a lot faster with much higher throughput than what you'll get in other places in the market. And so that's kind of the way that we approach it. We've built over the last several years a model serving platform that scales up and down to respond to the load that you have. And so we think that's like a best-in-class offering for serving LLMs in production. And so the question about Spark versus Ray is almost like orthogonal to how you would serve an LLM in production, because what you really need is to execute it fast and then to scale up when you need more. And so that's something that any platform, whether it be Ray or our model serving platform, which isn't built on Spark necessarily, can do for you.
Have another here.
So quick question, just given the large appetite for this technology, I'm sure that there's companies out there who want to implement generative AI or LLMs on their data that may not be at that point yet and ready for that. So if you were to put together almost like a checklist or like prerequisites that you would look for in a company to say like this is a good candidate and it would make sense for you to do this versus you need to take care of these things first before you're ready for this, like what would you speak to in that sense?
Maybe you could take that, Ben.
Yeah, great question. I think, a couple of years back, we would have, really focused on organizations and really pushing them to start to think about, their data strategies and how they might be able to, catalog data, store it in a centralized manner inside of some, think about, data warehouse, data lake, et cetera. But now what's happening is that a lot of organizations aren't waiting to kind of have their data strategies together, right? So what they're doing is they're using, with the large language models, technologies like LangChain that can allow you to really point to different disparate data set locations, right? So think about, there's a URL that has, help documents, and then there's another database that has SQL. Think about data that is for a specific purpose, and then they're pointing data to another location in a specific warehouse where you can grab data as well. But the idea is that now you're not waiting until everything is centralized. You can have decentralized data stores, and you're pointing to the LLM using that agent that we talked about earlier, where the agent is making a decision to say, hey, there's all of these different locations of data inside the organization, and I want to pull them in, and I want to structure them, possibly ingest the data as embeddings inside of a vector database, and in real time, and still being able to use that information to leverage through the large language model to provide a response. So organizations a couple of years ago may have had to wait, but now organizations are using large language models. They're using the LLMs as a driver, and then they're pointing to different disparate data set locations across these organizations, and they're able to kind of even without the data strategy being in full effect, still be able to leverage these large language model technologies. That's a great question.
We have another question over here.
Just one more point to that is I think everyone should think about starting from value, right? You need to have a valuable use case for your large language model application and then figure out how to use the LLM. If you start from an LLM, then you're going to go looking for applications, and that's often the wrong way of approaching it, I think.
All right, we have time for one last question.
Very well. First of all, thank you for the interesting discussion. Based on this trend of growth in terms of quality and variety of open source LLMs, I'd like to go back to this a bit of a future view. How do you see this evolving in following months?
So, can you elaborate a little bit on in what direction? Do you mean from the how the market or the open source world will evolve, or the use case? What?
Exactly. I mean, if we compare this to perhaps last year, where this was more, we had a few monolithic providers which had the good quality LLMs, and then through both via more intense collaboration of the academic community, but also certain leaks of model weights, we have this growth in open source. How do you see this coming forward as users of LLMs?
Yeah, I think that's a very interesting question. I think nobody has a crystal ball, but based on how the last 6 months have gone, I think the fact that the large companies have kind of large troves of data, large kind of amount of resources to train these models is counteracted by the fact that there's so much interest in this. The open source community has continuously iterated over new interesting ways to make things cheaper, make things more accessible, collaborate. So things like LoRa to make fine-tuning much cheaper, all these massive data sets that are available, like the stack that is scraped from GitHub. All of these things, I think, make it very likely that open source won't really fall behind too far. And the fact that in a lot of cases, having more control over these models, over the way that they're trained, and over the way that inference is happening, I think a lot of companies will end up leveraging open source for a good amount of the use cases. That said, getting started with kind of vendors who are offering kind of pre-trained models for specific use cases at a very high quality is a really good way to get started. So I think my expectation would be that that's going to evolve further the way it's been evolving in the last 6 months, but it's really difficult to say.
Yeah, I would just like to say that a couple of years back, Ali already envisioned, in the Data and AI Summit, we used to say, the future is open, right? And from where we are, in the past 6 months, working with customers, very closely with them, I can tell that every single organization, every single vertical, and every single use case will be touched by AI. And everyone will become super productive. So the differentiating factor will not be that you use AI. Differentiating factor will still be what business value you provide. So for all the organizations that are looking at AI right now to enable them, that's just one of these steps. The next step will essentially be to make sure that you hone in on the business value, because that's where your real company value will be, rather than, hey, how can I use the most state-of-the-art model, or how can we deploy it, or how can we use that? That's not going to be as valuable as it seems right now.
All right, well, that's it for this session. Please feel free to ask us things later, and thank you so much for being here.